Hey everybody, this is Larry. This is day 19 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today's poem is Link List Cycle 2. So the second one, is that the one with the pointer? Yes. We're doing the node, right? Okay. Yeah, so what is -1? -1, is it just return none? Yeah, I think it just return none, right? Oh, do not modify. Wait, no, we're not modifying it. Given the header, return the node. Okay, return none. Okay, fine. It's actually the first line. I just read it backwards. Okay, yeah. So this is the one where you have to actually do a return. First of all, I think the first thing is, you don't know how to do this, or at least how to do the first step of detecting a cycle. Definitely go. I think there is a previous problem where it's just detecting a cycle. We'll go over it really quickly, but you get two problems at the same time, I suppose, if you haven't done it yet. But the idea is that you have 2 pointers. There's a couple of names that go by this, but basically you have a fast pointer and a slower pointer. And then if there's a cycle, so there are only 2 cases, right? There's a cycle and there's no cycle. If there's a cycle, then eventually they'll catch up. Let me actually pull up Paint real quick. Let's see. Oh, that was already up. Huh. That's awkward. But anyway, yeah. Let's say you have some node, and there are only 2 cases, right? One is no cycle. No cycle is kind of obvious if you have 2 pointers. Eventually, this goes to none, right? Eventually, you just go outside and then you'll reach a none, and then you're happy, you're good, you're living your life, and there's no cycles. However, if there is a cycle, right, then eventually, because of I guess, do I want to say induction? But the idea is that if you have one pointer that moves twice, and then one that goes one, then here, let's say you start with here. Yeah, let's say you start here, and then after one step, you have one pointer here and one pointer here, right? After 2 steps, you would have one pointer here, and then the other one would have gone 2 more here, right? So then the idea is that the fast pointer will gain one, will basically gain one once it enters the loop, right? What I mean by that is that every iteration, every step that the slower one takes, the fast one takes 2, so that eventually it'll catch up to it because of, I guess, is it induction? I don't know. But like, let's say the distance between them is x. After one iteration, it'll be x minus 1 and so forth, right? So that's basically the idea behind that, and that's, to be honest, is one of those trivia things. I don't know if you could come up with it if you haven't heard of it before, but I just feel like it's one of those things that, it just becomes like people just know about it, right? And when people know about it, it's so common. I don't even know if it's an interview question anymore because it's too common to be an interview question, but that's the idea, right? And then now, the idea is then, okay, let's say there is a cycle, right? There's a cycle. You have to try to figure out where their starting point is. There are a couple of ways to kind of represent this as a system of equations, is how I want to think about it. I actually don't remember this particular part with respect to like the formula or the code, so we'll try to see if we could prove it from scratch. So this part may be a little bit murky, and if so, then feel free to whatchamacallit, fast forward, watch on faster speed, or so forth. So, okay, let's say there's a cycle, right? What does that mean? That means that's the slow pointer. Let's say, how do I want to represent this? yeah, let's say let's say there's two parts, right? Let me bring out paintbrush again. Hang on. I think maybe that's a little bit easier for a quick visualization. But yeah, let's say you have this, and then let's say the part before the cycle is A. Let's use another color. Let's say the part before this is A, and then this part, and then the part where they meet will be B, right? Let's say they meet here. I don't know. This is just an example. Let's say they meet here, right? Then that's B. What does that mean, right? Then here we can kind of try to figure out the formulas is what I was going to say. And let's see if we can do that, right? So the slope pointer would move A plus B just by definition. So in this case, I think one observation to know here is that the slope pointer will not make one full cycle through because, like I said, no matter where the fast pointer is, let's say the length of the cycle is equal to c, and the fast pointer is one space ahead, right? Or c minus one space behind, if you want to put it that way. That means that it will take c minus one iteration to go, right? And of course, in that case, the slope pointer would only move c minus one case, so it would never make one full cycle. Just an observation, right? Don't know if it's a useful observation, but it is an observation because, like I said, I'm trying to prove this by from scratch and figure it out, right? So yeah, so then the faster pointer, of course, it goes 2a plus 2b, and then there's another way of phrasing it, right? So this is just 2 times the slower pointer, just by definition. And now the question is, can I use C in this, right? In either one? Let's see. Well, where do they meet, right? This is the part that I'm always a little bit sketchy about, and it's such trivia. Oh, excuse me. Oh yeah, and I think it goes without saying we're trying to do it with O of 1 memory, because obviously if we have O of n memory, this is even more, we just have a hash table, right, or lookup table or something like that, and that would be like a for loop and silly. So yeah, so let's incorporate cycles into this, right? So the idea behind this is, let's see, let me see if I could have my visualization up real quick. Yeah. So this means that there is some head. So the slower pointer moved from A and then will be part of the cycle. Okay. How far did the faster pointer move, right? Well, the faster pointer, when it moves to B, what does that mean, right? I mean, there's this formula as well, but that means that it moves A plus, because the A is the head, C is the length of the cycle, right? Do we use, let me think about this for a second. So bad at this. This linked list stuff is so useless, if you ask me, but that's besides the point. I know people could say that about anything, but it just doesn't really come up in competitive either. Not even, yeah, but okay. What am I saying? Okay, let's see. I'm just tired today. Okay, let's see, right? So A is the part. That means that it has moved. So B is the length that is traveled inside the loop. So that means that the faster pointer will meet pointer at B plus the cycle, right? Because the cycle is one cycle. We assume that the faster go one through and then catches up at B. Does that make sense? Hopefully that makes sense. Let me draw it up really quick again, actually. I think this is right though. But yeah, let's say we have this again. If we meet here, okay. Let's say this is A. Let's say they meet. Let's say they meet here, right? So then this is B, and then of course the cycle length is C. This is C, right? So that means that because in order for the fast pointer to reach all the way back to here to this point, it would have to go ooh, do, and then one cycle later, right? So of course, if you draw it this way, then it's clear that this is A, B is this part already, and then C is the cycle, right? The length of the cycle, just to kind of visually show the formula that we kind of that I have here, which I was trying to do it in my head, which is I think fine in theory, but you know I'm trying to show you a little bit, right? So okay, so in this case, then that means that, well, I mean obviously these two are the same, which means that this is the number of steps. This should equal to and of course this, if you subtract A and B plus both sides, then A plus B is equal to C. Is that right? That is, maybe some people just memorize this then. I guess it's very easy to remember. I just never, I don't think I ever remember this, but that's actually, if that's true, then that's good. I am not super confident at this particular point, not gonna lie. I'm a little bit rusty, and yeah, and you could kind of see me actually solve a problem that I don't really, you know, like this is almost like ad hoc-y weird problem, right? So okay, in this case, okay, so what does this mean? This means this is the length of the cycle, right? That means that the slow pointer has moved the length of the cycle by the time it meets. Man, that sounds really awkward, but is that true? Let's see. I mean, one thing that I like to do is to verify myself before I kind of invest more time in it is take a case and then see where it goes. Like for example one, what happens here, right? And you kind of like just draw it manually. So so move one each, and then two, and then three. I guess that is the. I guess that, I mean, it works for this one. So okay, wow, that is I guess that's how people remember it. Because I do know people like did this really quickly, and I'm like, I don't know, because I don't like memorizing these trivias, but I guess this one's actually not that bad to remember. But I don't know, I still don't like it, so that's why I don't remember it. But as you can see, you can kind of figure this out where I don't know about very quickly, but pretty okay, right? Okay, so then that means that okay, we know the cycle length. So then how do we how do we get the starting pointer, right? And the pointer is of course just A. That's basically effectively the answer that we're trying to get, which is A. So then we're already, so then here, what is A, right? A is equal to, of course, C minus B. But can I represent this in terms of motion? Dong dong dong. Okay, so we have A. Okay, so the length that it goes is the length of the cycle, right? So what does that mean? So that means that we're in the cycle, and this is the length of the cycle minus B. That means that if we have a pointer that moves B, would that give us A? No, but what we want, so A is equal to this stuff. Man, I am not knowing this at all. Hmm. So we want to find A, which is C goes to B, but I'm trying to think about how to do pointer arithmetic because we don't actually, in theory, know C or B. But if we move, is that a good way about it? Let's see, right? We also do have all these other things. So basically, if we move another A plus B, we get another cycle. So is that helpful? Don't know. How do we find A or B then, given these things? Dun, dun, dun. Okay, so we have a fast pointer. This part I'm a little sketched about. Let's see. So let's say we have a pointer, right? So what happens if we have another fast pointer? I'm just like throwing up random ideas. If we have another fast pointer and we are at C, then effectively what we're doing is adding A plus B on the slower one. And then on the fast one, we add A plus B plus B plus C, right? Which I guess is just adding 2 cycles on both sides. Does that help at all? Where do they meet? Man, this part I'm really bad today. Okay, so let's say we have this thing and we want to add, or maybe this thing, right? So we're at, actually, let's step back for a second, right? So so we know that this is the length of the cycle, and that means that we know that so that means that if we add another A, then this is the cycle and this will be C, and then we'll get A. Okay, I think that's how I do. Sorry about the red herring. Yeah, okay. I think that's how you do it, right? Is that okay? You have A and B on the slope pointer. If let me say it in a way that I think I understand now. Do I have the thing sparking up? Okay, so now we have A plus B on the slope pointer, and so if we add another A to this, then we know that this is equal to C, which is equal to because if A plus C is of course equal to C. A plus C in this linked list arithmetic is equal to A because C just cancels out, right? Like it just loops around. So that means that in the beginning we would have A. So that means that from here, from where we are now, we have to move another A, right? And we move another A. Maybe that. Well, okay. Maybe that doesn't make sense actually. Now that I think about it, or like it makes sense. But how do I get this again? I think I had some idea in my head, but now I'm a little bit lost again. Whoops. I mean, what I'm saying is right, but how do I get that again? Okay, so we have A plus B, and let's say we move. How do I move another A? I mean, if we know how to move another A, then we just know the A, right? So that's actually maybe a circular logic thing. Man, I'm really bad today on this one. Let's see. Maybe that wasn't the right way to go. I was gonna do something like, okay, maybe if we add another Hmm. When would it? Okay, I guess my question is when would this? Like, if we start another fast pointer from the get go, from the beginning, right? Um, okay, maybe I'll write it here. Let's say we reset this to 0 after finding this thing. Let's say we run another until they meet again. What does that mean, right? Does that mean anything? Because now what happens is that one cycle is going to be one cycle is going to be C, I guess. Though it could go many cycles, right? So, because A could be large, and then the fast pointer would catch up one at a time. Is that even? Wow, I really have no idea how to do this. Today, anyway, because I feel like I've done this before, but I'm missing. Okay, so we have this thing. Where's the faster pointer again? The faster pointer is A plus B plus C. Oh yeah, we knew that because they're both at the same place. That's how they meet. Okay. How do I just get A then? Let's see. How is there a way I can move just B steps or A steps? I guess if we just add A steps, then this would be not trivial in a way, as we already said. Well, oh, I see. Is that true? No, I guess not. I was gonna say maybe we could, like we could calculate this by sending another pointer moving C, but that doesn't really change anything because now we know the length of C, but we do not know A or B. What if we? No, that doesn't make sense. I was gonna say, what if we send a second slow pointer, but it's also there's a chance that they just never meet, right? So that's just silly. If we have a second fast pointer, where do they meet? I guess I was a little bit lazy. Not lazy. I just don't know how to do that one. Right. Then that means that the fast pointer is going to be A plus B behind. What happens if we have a second slow pointer? Okay, I think now I remember the idea that I kind of lost a little bit because I confused myself, which is actually ridiculous now that I think about it. I mean, I actually alluded to the same ideas, but sometimes math is just ridiculous, and it's also one of those things where if you knew the answer, you could prove it easily. But I don't know how people come up with stuff like this. But the idea is the same, right? Is this plus A is equal to C plus A? So this is of course now we have C. But the idea is that and we kind of touched upon this before. We add A steps on each side. But the key thing to know here is that this means that the 2 pointers meet at the same time and a second slow pointer. I think that's basically the idea here. Because okay, let me bring back the paintbrush thingy again. So basically, let's say we have here, right? And this actually may not be true because I might have missing some notes, but actually no, this is actually right. But I don't know by accident really, but yeah. But let's say they meet here, right? That means that because this is A plus B here, and we know that another additional A, this completes the cycle because that's also the definition of A plus B. But that means that because of that, if we have another slow pointer starting in the beginning, they will meet at exactly here because this A is equal to this A. I think I had the math right, but I missed the visualization in which they meet at the same point. And if they meet at the same point, then you could just return that answer. This is also honestly a ridiculous problem if you haven't done it or seen it before. I've seen it before, and I refuse to remember it or memorize it because it's not really, it's just one of those things either you remember or you don't. And I don't put any effort into memorizing this because it's whatever. But that said, that's actually amazing. So that allows us, that's it, right? The tail, if you send a second slow pointer, they intersect at the starting point. Okay, so this is already a long video, but hopefully you kind of see my thought process, including a couple of times where I was very close. Like I saw this idea, I just saw the mathematical thing, but I think I confused myself with the math with the visualization and also what it means physically, right? In terms of the linked list. And I think once we kind of put that all together, everything's good again. Okay, let's get it to yeah. Let's get started on this then. And this hopefully, even though it's really long, and I hope you watched it on a faster speed until at least the end. Hope this is a very good understanding problem because this is hard if you haven't done it before. So yeah. Okay. So then now we move, and this is what I'm doing now is just a very, this part I say is standard with Freud's algorithm, and it actually comes into play with different other problems as well, which is why I know it, because in this case there's a linked list, right? Of course. So, and like I said, I don't care for linked list per se because it doesn't come up that much, but you can actually use this on other things that are not linked list but has a linked list thing, right? Like one thing that is used is if you have a function, like if you have, for example, f of x, and you want to see is there a cycle. Let's say you have x to f dot, right? Is there a cycle? And of course, in this case, Freud's algorithm would be the slow and the fast pointer could be used to solve this in constant space if that's your need, right? So there are a lot of like stuff like this, and then you could kind of even do another loop to get the entry point again, which is kind of, like I said, kind of miraculous. But in either case, yeah, maybe I could use that because I think actually interestingly, a couple of days ago I did a code force problem where I was running out of memory. Though this is a little bit slower, so I don't know. But yeah, so maybe that could have been helpful. Anyway, so yeah, wow. How do I want to write this? Yeah. While fast is not none, fast is equal to fast.next. If fast.next is not none, if fast is not none, fast is equal to fast.next, slow is equal to slow.next. This part I'm a little bit sketchy about, in that I always forget how to write the loop in that there's not an off by one. But if this is a little bit off, I'll have to just modify it. But yeah, if they're the same, then we break. And of course they're the same, so you could just take either one. Doesn't really matter, right? Like, so we'll just set slow is equal to head again, and then now while slow is not equal to head, slow next, and then just return slow. again, again, it doesn't matter which one you return because they're the same, right? That's the invariant. Let's give it a spin. Maybe I'm off by one, maybe not. Hopefully not. Okay. Let's see. Oops. Add a few more cases. Oh. Oh, I whatchamacallit? I didn't do the case where yeah, I didn't do the case where this is true. Yeah, the non-link, the non-psycho case is what I forgot. And that looks okay. Let's give it a submit. Done it apparently, is it a year and a half ago? Okay, cool. Yeah, that's all I have for this one. I know this is a longer video, but I hope that I mean, because to be frank, this is a problem that a lot of people have videos on. So I don't really, like, I don't feel like, if you only want the answer, then I apologize. The video is a little bit long, but if you want to see how someone whom have some idea but wanted to kind of the thought process about how to solve this problem from scratch, not really scratch, I'm not gonna lie, but like to solve it live. Hopefully, this was a good attempt to kind of visualize that. Let me know what you think. Let me know how you did. Let me know if you did it in constant space. That's all I have. Stay good, stay healthy. To good mental health. Have a great rest of the week, and I'll see you later. Bye bye.